In this tutorial, we will implement a simple REST API for managing users using the Express.js framework and a MongoDB database. Before starting implementing our REST API, we have to install first Node in our computer. We can download Node from the official website. The last stable version is the number 12, but you can download any other desired version. I suggest you to use a tool called NVM, also known as Node Version Manager. NVM allows us to install and manage multiple Node environments easily. We can list all the available Node versions we have installed running the command nvm ls. The active Node version in my computer is the number 10, but I can switch to another version just running the command nvm use, followed by the version of my interest. Now, if I check the Node version, it says I'm using the version 6. As I am interested to implement the REST API using the version 10, then I go back to reactivate the version 10. The first thing we are going to do is to create a project. Node comes with a built-in tool called npm. npm is the default package manager for the JavaScript runtime environment Node.js, and among many other things, it allows us to create, install, or share packages that can be reused by other developers. The next thing is to create a project folder. I call it User REST API. Next, we will create the project package using the command npm init. Now you will be asked to enter the basic data of the package. Just enter the name, version, and description of the package. The rest of the fields can be modified whenever we want later. After filling the form, it will show a JSON with a summary of the data entered. That JSON is the content of the file package.json that will be created after checking and confirming the data. Now, if we list the content of the project folder, we will see a file named package.json, which is the base of any Node project. Next, we create the Readme file. With the command git init, we create the Git repository. We can see that both files are not yet staged, so we can add them just running the command git add -a. After that, we will make the first commit with the command git commit -m, followed by the description. Usually, the first commit is described as the initial commit. We will open our favorite code editor or ID. I usually use the Atom editor. Next, we load the project into the editor. We will start by creating the file server.js, whose main function will be to launch the server where our REST API will run. First, a message will be shown to indicate that the server is running. Second, we create an instance of the API server class that we will implement later in another file. The parameter of the constructor of this class will be the server port. In this case, I use the port number 1992, but we can use another port as long as it is not in use and the operating system gives us permission to use it. The call to the start server method will be used to start the server. Personally, I use a folder called source, where to include the source code of the different modules that I will implement during the development of a project. Each developer organizes the code following the structure that is most comfortable for him or the one that suits the project. In this development, I will create the source folder, and within this, I will create the API server folder. In the API server.js file is where we will implement the different endpoints of the REST API. First, we will start by doing a very basic development of each of the endpoints, without making any connection to any database, so that for each API call, we will return a valid HTTP code and an empty response. For that, we just need to use the Express framework. We create a new module to export the implementation of the class. First, we will import the Express framework even though we have not installed the dependency yet. Therefore, if we now run this code, Node will give us an error. We will install this dependency later. Body parser is part of the Express framework and will allow us to have HTTP content treated as JSON objects. Next, we will specify the list of allowed origins so we can control from which domains we authorize API calls in web browsers. The list of domains will be loaded from a configuration file that will be created specifically to store such data and also the data needed to connect to the database. We get the value of the origin header from the request and verify that it is among the allowed origins. If the origin of the request is unauthorized, then it must be communicated to the browser. We will also indicate which methods and HTTP headers are authorized in our REST API. Next, we create an HTTP server instance and link it to the Express instance that we have previously created. In the next step, we will implement the start server and stop server methods to start and stop the server respectively. Now it's time to start implementing the different endpoints that will define the API. Since the intention of our REST API is to be able to manage a very simple database of users, we will just provide an interface that allows us to create, obtain, modify, and delete the data of a specific user, and, in addition, to obtain the list of all users of the database. The init endpoints method of our class will be in charge of the initialization of all the endpoints. The first endpoint that we will implement will be a post to the user's path that will allow the creation of a new user. Later, we will work on connect, read, and write operations of the Mongo database. Therefore, we will now focus on defining all the endpoints and returning 200 status codes and closing the connection without returning any data. The next endpoint will be a get to the user's /ID path to obtain the information of a specific user. We add a colon as a prefix to the ID parameter of the path. This will allow us to obtain the value of such identifier parameter when a call to this endpoint is invoked. I return a status code 200 to indicate that the operation was successful and then close the connection. We continue on the same way for the endpoint responsible for deleting a user. We do the same with the endpoint in charge to modify the data of a specific user. At last, we end with the endpoint that should return the list of all users. We can see that creating endpoints with the Express framework is quick and easy. Before start the server in the terminal, we have a pending task. We have to create a configuration file where we are going to define all the allowed origins that will be loaded when running the server. In the list of allowed origins, we will put the localhost domain on port 4200. Usually some frameworks such as Angular or React serve web pages in this domain and port when they are running in debug mode. So our web server will accept API calls that come from this origin in a web browser. With all those endpoints already defined, we will try to start the server by executing the command node followed by server.js. We will see that node will give us an error, because in the implementation we used the Express package, and we have not yet installed it. We will install it in our project with the command npm install -s, followed by the name of the package to be installed, in this case Express. Once installed, we will observe that in the root of the project a new folder named Node Modeless has been created. This folder is where all the dependencies needed for the project are installed. We will restart the server, and this time we should have our API serving through the port 1992. In the browser, we can try to call directly the endpoint that obtains the list of all users. It returns a 404 code. It means the server is telling us that such endpoint does not exist. After reviewing the code, we see that the method to obtain the list of users is not a get. We fix it and restart the server again. Perfect, now it returns a 200 code and an empty response, as expected. The next step will be to implement the different calls to the database. In our case, we will use a Mongo database. We will download the MongoDB Community Server tarball from the official page. We choose our operating system, in my case, a macOS. The latest version today is the 4.2.3. We copy the download URL. We download the tarball file in a temporary folder and unzip it. Then we copy the binaries into a new specific folder only for the Mongo. Now we create the folder where the Mongo will store the databases and start the Mongo server using the dbpath parameter to specify the folder where the data should be stored. Now that the Mongo server is up and running, we will connect to it in order to create the database for our REST API. To make this, I recommend using a free tool named Robo3T. Once connected to the Mongo, we create a new database and we will call it, for example, API. We see that there is no any collection in the new database and therefore it is empty. Before start to implement the operations for reading and writing the database, we will first create the database.js file. This file will be used to implement functions to easily open and close connections to the database. In the configuration file where the allowed origins are defined, we will also store the name of the database, the credentials, the address, and the port of the Mongo server. Before continuing with the development, we will make a short pause to commit all the changes in the code we have made so far. In the gitignore file, we will add an entry for the node modules folder, as this is not necessary to be stored in the project repository anymore. Whenever we want, we can generate this folder with the npm install command. We add all the files we have implemented in the git stage and perform the commit. The next step will be to implement the read and write operations against the database, but this will not be possible without first creating a specific collection in the database to store all the users' data. We call this collection users. Now we begin to implement the functions to create, edit, get, delete, and list users, making the proper calls to the database. For this task, we will create the Users Manager module that will export the functions of all the scenarios mentioned. This module will later be used by the API server class. We import the database.js file to allow us to open and close connections to the database. We also import the MongoJS dependency that offers to us an abstraction API to implement the read and write operations. The function I'm going to implement first is the function to update the data of a specific user. First, we get a connection to the database. We specify the collection that we want to perform the action just by treating the collection as if it were an attribute of the database object. To this attribute, we invoke the function of our interest. In this case, we will perform an update. The first parameter of the function is the filter. The second parameter contains the new data that we want to apply to the document. The last parameter corresponds to the function that will be executed when the operation finishes, and this is where we will get the result. At the end, we must always close the connection to the database. For simplicity, I open and close a connection to the database every time I need one, but we can optimize this process by making a pool of connections that allow us to reuse them. All available read and write operations can be obtained by consulting the documentation of the MongoJS library. This library is still an abstraction of the API of the Mongo, therefore, the official documentation of the Mongo can also serve as a reference if we want to explore all the possibilities of this powerful database. We continue with the implementation of the rest of the functions following the same way we did in this first one. Finally, once all the remaining functions of the module have been implemented, we will finish the implementation of the API server class using such functions. First, you have to import the User Manager module. The first endpoint that I will update will be the one in charge of creating new users. I will remove the previous dummy code and add the call to the create user function, passing the JSON parameter with the data of the new user that we obtain from the content of the HTTP request. The second parameter will be a callback function that will be executed when the insertion of the document to the database finishes. In case of success, we will return status code 200 and close the connection, returning the data of the created user. If on the contrary, the operation does not finish as expected, then we will return an error code such as 400 bad request or a 409 conflict. In this example, I will return an error code 500 just to simplify. We will update the rest of the endpoints the same way for each of them. We go back to the terminal and start the server. We will see that Node gives us an error because it does not find the MongoJS package, so we install it. The installation downloads and saves the dependency files in the Node modules folder and updates the package.json file. We'll restart the server again, and now we can test the REST API we have developed. In order to test it, I will use the Postman tool and start with the endpoint that obtains the list of all users. It returns an empty array because we haven't created any user yet. The next thing we will do is to create a user by posting a JSON with the new user's data. we observe that the response of the call contains the JSON document that has been created in the database, and in this document a new field appears and corresponds to an identifier automatically assigned by the Mongo. Later, we will modify the code so that the API responses do not include this field in the future. Then we get the list of users again and see that the new user appears in the list. We can add as many users as we want. We will try to modify the data of a user. Now I will check that the endpoint to deleted user also works fine. And finally, I will modify the code to remove the Mongo identification field from server documents, so that it does not appear in the results anymore. Before concluding this tutorial, we will save all the changes we made so far in the code, making a last Git commit.